Cooling is a hot topic in the data center industry. Few companies have been more focused on cooling than Aligned Data Centers. Our guest today is Michael Welch, the Chief Technology Officer at Aligned. Michael discusses how Aligned is updating its products and designs for the rising densities in AI workloads, and why an advanced cooling lab is an important part of the company's strategy. Let's get started. Welcome to Data Center Richness. I'm Rich Miller, and I've spent 25 years telling the story of data centers, cloud computing, and AI infrastructure. In this podcast, I'm sharing conversations with the innovators building our digital future. Now, here's our show. Michael Welch, welcome to Data Center Richness.
Hey, Rich. Long-time reader, first-time caller, interviewee. Happy to be here. Thanks for having me.
It's great to have you. I thought a great starting point would maybe be for you to tell our listeners and YouTube viewers a little bit about yourself and your background in the data center industry, and then talk about Aligned and what it does.
Yeah, absolutely. So, Michael Welch, I'm Aligned Data Centers Chief Technology Officer. Been with Aligned for about 14 years, actually, in various roles. Started as a project engineer for a company called Intertech, which not a lot of people know, but was the founding business of Aligned back in 2011. Started doing modular data centers up in Canada, actually. Gravitated more and more into the engineering field and into product development while at Intertech. And in about 2015, we transitioned the business into building our own wholesale and hyperscale colocation facilities. A few years after that, I moved out of the project engineering and product engineering and into supply chain, really to try to build Aligned's program and supply chain across the portfolio in the States. And over the years, have kind of grown out of the supply chain back into kind of being accountable to Aligned's engineering for the facilities, our power generation teams and land enablement teams, and our customer program management teams. So it's been a very, very interesting, fun journey with Aligned. We've seen the data center industry just explode since we started to build those facilities in 2015, and very proud of what we've built here and what we're going to be building here in the near future. I think you probably saw our large announcement in Ohio, and that's extraordinarily exciting. We're very, very bullish on the space. When it comes to a little bit of our view on the market, I kind of take an AI arms race approach. Everybody wants to get their model out into inference and consumption as fast as they can. And in order to do that quickly, they need capacity. And they want that capacity to be contiguous. So that means big power, one spot. How fast can you get it to me? And so at Aligned, we are looking to match that speed and hunger with some of our products in our portfolio around our modular products, our AMI, and try to keep up with the speed that our customers are really demanding at this point. So it's a pretty exciting time to be in the data center industry. There's a lot of technical change. There's a lot of growth, and we're looking to keep pace with that.
Yeah, I know you guys are building big in a lot of places to keep up with all of this growth. It is kind of in terms of demand and the level of activity, a pretty crazy time. It was interesting to hear you mention Intertech because that kind of goes back to the very beginnings of Aligned. And one of the things I wanted to talk about today, where we often lead with cooling, and cooling and engineering focus has really been a part of Aligned's story from the very beginning. But these are kind of interesting times for cooling. Tell me a little bit about Aligned's sort of legacy in advanced cooling and how you guys are looking at the space and the customer requirements for cooling here in the AI arms race of 2025.
Yeah, great question. I like to talk about we say a lot like Aligned's DNA, and how we operate as a business and our culture. And a lot of the innovation in the cooling side was Bohr back in the day with Intertech when we had some pretty novel cooling patents and inventions around optimizing efficient systems using basically it was actually pretty novel at the time. It was refrigerant to the rack for the most part. And so that DNA and that hunger to try to improve the efficiency of these systems lives on today in our Delta Cube product, which a lot of our customers are well aware of, and in our new CDU, which is our Delta Flow unit. And so really, the way I like to look at it is, in order to bring to market a product in the data center vertical, it starts really with great information coming in from where your customers are looking to go and what they're telling you. It comes from your partners. Where are they seeing? What trends are they looking at? It comes from the hardware folks. And so I'd like to think part of my job is to try to gather all that feedback and understand where things are moving and heading so that we can position ourselves to be successful in supporting that capacity for our customers. And so in the 23, we recognized that liquid cooling was coming. And we didn't feel like the supply chain and the product mix that was available in the market could keep up with the demand. Go from 2% of the data center portfolio being liquid cooled to what could be 60 to 70% next year is a massive supply chain shift. You add that on top, you add the supply chain shift, and then you add your facilities under development on top of it, and you realize you have to have an adaptive product that you can install on your facilities to keep up with this loads and to where things are going. And so we set out to develop the Delta Flow unit, and that unit is been installed in our lab and is now out in our data centers now supporting loads, and we're really excited about it. I think that product itself in its own right is going to continue to iterate, potentially go up in size, potentially handle warmer flow rates, as there's more flexibility in terms of the secondary fluid network temperatures. And it'll keep pace with some of the advancements at the chip level. I do think we're going to see, as densities continue to climb, you may see some two-phase directed chip sort of cooling coming, and we want to make sure we're positioned to support that as well. And so kind of a mix of how do we use our DNA to develop these products to make it easy for our customers to build out these hybrid environments, both liquid and air, and be flexible enough to keep up with the chipsets that come out. That's a big part of the conversation, is not knowing exactly what chip or what rack you may get. How do you build an environment that's flexible enough to that the 6 weeks before racks roll in, they can lock it down and we can stand at that capacity.
Yeah, it's an interesting time in that way, thinking about the evolution of cooling. And I want to talk more about hybrid designs. Uh, you mentioned Delta Cubed. That's been a system that's aligned to support customer requirements of up to 50 kilowatts a rack, which used to feel like extreme density. But of course, we're seeing more than that from some of the new AI gear. Delta Flow, I took a look at some of the docs on that. It looks like you've got obviously a lot of capabilities in providing water to the floor and to the pods out on the floor, but also then a lot of flexibility with what the customers can do within their environment. Tell me a little bit about how you thought about approaching Delta Flow and how folks would use it.
Yeah, so one of the first principles of developing that Delta Flow was that flexibility to, I like to say, like mix and match at the data hall level. Like depending on whose chip you're using or what generation of chip, you could see anywhere from 60% liquid cooling requirements to 95% liquid cooling requirements and you're trying to make up the rest with obviously the air cooling, unless you're going with immersion or another technology that would put more into the liquid loops. And so from that perspective, with the data halls, you need to be able to support both. And then you add on the dynamic of, if you don't know exactly what stack you're going to put on the floor, you generally need to over provision the heat absorption to cover your worst case in both directions. So you may have something that's 90-10, that's your base case, but your fallback case is you got to put something in that's a generation older, and it actually could be 70-30. And so you end up with sort of like this 30% air cooled design and a 90% liquid cooled design to add to 120%. Your back end infrastructure can't handle 120%, still size for 100%, but you have that over provisioning on absorption. And that flexibility to move those parts and pieces in and out in the same footprint. So the delta flow and the delta cube are actually the same footprint, same power consumption, even though the capacities are a little different. That allows us to be nimble enough to adapt to that and give that flexibility to these customers. But we are definitely seeing nearly everybody over provision on heat absorption. Everybody is aware of the cap. We also want your chilled water plant to kind of not know the difference between whether it's taken a lot of energy from a liquid cooled secondary fluid network piping or from the air side. And if you have to start making adjustments to your chilled water plant and your heat rejection to accommodate that, you're into more larger changes that are more impactful. And so the way we've designed these products is that they intermingle, same chilled water temperatures. Chilled water plant doesn't know the difference, but we can provide that flexibility to the floor.
Let's talk a little bit about hybrid environments. This has been one of the sort of shifts in focus on the design front, as lots of customers, as you mentioned, may have some workloads they're running that are still designed and optimized for air cooling, and now they have this new equipment coming in. Uh, for a lot of designs, and a lot of folks have had to kind of think about updating what they're doing to be able to have that flexibility. Uh, One of the things Aligned has talked about in the past is the ability to have racks of different densities in proximity to one another, maybe even within pods. How does that work? Are you, in terms of what you can provide customers who have those type of heterogeneous workloads?
It is a coordination game when it comes to these hybrid environments. So the way that these pods look like with these hybrid environments is we'll still have traditional hot aisle containment. We'll still have a common return plenum, and the densities of even the network racks for some of these pods is still, you know, I'd say 30 kilowatts plus, right? It's still even high density air cooled. And then what we do is we coordinate how we install the secondary fluid network piping and associated controls devices to make sure that we can actually include and fold in the direct-to-chip cooling. So you end up with this really coordinated, dense pod and infrastructure that is tied back to what is like our mechanical gallery perimeter. So we are a perimeter installed CDU and a perimeter installed CRAW unit. And at the end of the day, you're doing a CFD to ensure that air is getting to where it needs to go, and that may facilitate some movement of a hot aisle here or there. That may facilitate the width and height, maybe potentially tweaking a little bit. Um, but what we've seen is it's the liquid cooling portion of it, because of the amount of energy you can move per cubic centimeter of liquid. You can get to these high densities even when you fold in the 20 to 30% air side. It just becomes a very last mile handshake with us and our customers on how to make sure we can, again, look to cover their bottom lowest common denominator approach, where they may have a technology that's here, and their optimal rack or stack that they want to put in that facility, and what kind of flexibility do we have in that pod. And so as long as you have the perimeter heat absorption devices provisioned properly and then coordinated well on the floor, you can install these systems and have them function and provide that flexibility to these customers. And that chilled water plant, again, being, I'd say, like the central to the entire system. Obviously, you want it to not know the difference as to, again, where it's getting that watt of energy from.
And as I recall, you generally have pretty high ceilings in the data halls, so you have a lot of flexibility. If you have folks who want to have taller racks or go up a little bit.
Yeah. We've 18 feet is the lowest we would see a drop ceiling in our hall. That ironically has been that way for us for about 6 years, I want to say. That's also kind of tying out to what we're seeing in a lot of literature now to squeeze all this in. It's not easy to route all this in a lower, height ceiling environment. You have, not just the SFNs you've got to deal with, but you have potentially leak mitigation. You have different controls devices that are added for the secondary fluid network devices. You have 60 to 100 amp whips. You have RPPs to coordinate with. You have multiple layers of networking tray to coordinate with. So what we found is you need space, and then you need the ability to either support somebody from the floor or hang it from the ceiling. Weight comes into play as well, and so having the the bones of your facility in the right place is so important to being able to deploy these advanced compute hybrid environments. And depending on the facility you're working in, it's going to dictate what upgrades you may need to make. Like I like to think of this in kind of phases. You kind of like a legacy data center phase, right? Which could be direct outside air economization. It could be these different designs, and modifying that into a hybrid environment is going to take a different level of effort. Then you have maybe facilities that are being adapted that were in development over the last couple of years. And as you know, to develop a data center ground up, there's a pretty long permitting cycle. Although the administration is trying to help us, produce that. And you're adapting those facilities that were designed for the new advanced compute reality. And then I think in the near future, we're really going to have optimized facilities around it from the beginning. So you can take advantage of what some of the advanced compute systems will offer you, like the much higher density to reduce, square footage. I like to call those, positive feedback loops. If you can reduce the square footage of your building, it's not just an economic savings. It's also, hey, it's less parking if I have a parking requirement. It's less stormwater retention requirements because I have less parking, and you kind of just realize all those benefits. So you can go higher density. You can start to raise the supply water temperature of your chilled water plants. You can potentially divorce your loops. You really start to optimize around some of it. And you can reap those benefits. So right now, today, a lot of what's being built, right, is adapted. It's adapted from a more traditional facility that maybe had some infrastructure added to support this, and then we're moving rapidly into optimizing around some of that, and that's pretty exciting to me, and I think a lot of others.
You mentioned the importance of communicating with your customers, hearing what their needs are and where their infrastructure is headed. You guys recently created an advanced cooling lab, and I'm interested in what the genesis of that was, what that facility is going to do, and sort of its role going forward as Aligned continues to try to move with the customer needs.
Yeah, really proud of the advanced cooling lab that we built out in Phoenix. Um, it serves it served and is continuing to serve as a great value adding tool for us, our partners, our customers, and even potentially chip manufacturers. So really the genesis of that was when we sat down to say we want to make sure to develop our CDU uh, product for our portfolio. You know, developing products in the data center industry is not like putting out an application for the iPhone, right? Where if you have a bug, you just issue an update, rock and roll. We have to make sure that we get this right. It's reliable, it's efficient, it's scalable. And so right off the bat, building a lab to validate all of that was the baseline of our development process. And as we started down the path of designing that lab and building it out, we really realized that this is not just about validating our product and approach. It's about training our operations team on how to operate secondary fluid network systems. Like those were uh, a small percentage of portfolio. They're going to be a much wider percentage, and you're not going to have the same operational base of people experience with it as you do with air cooled systems. When it comes to these liquid cooled systems, the buffer is basically gone. Any impact to any system is being seen at that direct chip near instantaneously. So our build teams to practice those processes, make sure the quality was in the right spot, do all the testing outside of it being in a mission critical environment with a date that they've got to hit for a customer. And then our partners, we've had our partners come in um, and really see, particularly around like transient performances, things you wouldn't think about. Like running a loop is one thing. Watching the power consumption go from 50 kilowatts to a megawatt instantaneously, and how does your CDU respond to that, and how does the chilled water system respond to that, is one you want to do in the lab. You don't necessarily want to do it when you have the live load in your facility. So that investment in that lab has been allowing us to really hone our process and plan, make sure our product is in the right spot, and then really get ready to scale it.
Yeah, it seems like as we've seen the development of some of these AI systems move to higher power envelopes pretty quickly, honestly. Looking at most famously, the NVIDIA roadmap over the next few years out through like the Rubin Ultra, it looks like these are all the kind of implementations and deployments that really need a good testing setup to be able to see exactly how they're going to work as things move more quickly on the density side.
Yeah, absolutely. We are partnered with lots of different hardware providers, including customers who are procuring hardware from lots of folks and offering them the ability to install that hardware in our lab and see how it functions in really what is a realistic data center environment. Provides a lot of value for not just them but for us. When it comes to guaranteeing an SLA and uptime, and we want to we want to have that coordination. We want to have that practice before we get into the game.
One of the interesting things about extreme density is that the waste heat gives you some opportunities. Typically, you're working with, you know, temperature deltas and then higher temperatures for waste heat, which gives you more options there. I gather this is something you guys have thought about. I've always been a fan of waste heat and reuse as something that, sometimes makes projects more interesting to the community. Uh, are you guys thinking about that? Do you see opportunities to do more, waste heat involvement in the kind of projects you're building?
Yeah, I see it as maybe two steps. Um, I see the first step and maybe the more obvious step as, when you can raise the supply water temperatures for your plants and improve the delta T's of those systems because you're getting the warmer return water temperature because you get the performance from the liquid cooled chips. Like you can increase the economization potential for your plant with that much warmer return water temperature. So when you increase the economization potentials, you're reducing your energy consumption. There's some positive feedback loop generated by that. So the first thing is like how can you make your systems more efficient with that warmer water, that lower flow rate, and that is definitely part of that optimization phase that I was talking about. And then the second thing is definitely like the holy grail to me of like data center development is like at the end of the day, we're sort of a giant toaster oven. We were right. Like energy comes in, it is goes through a server, it comes out as low grade heat, and it needs to be rejected to the environment. This optimization around advanced compute and liquid cooling allows us to potentially look at how to use the heat to either generate electricity or provide another benefit. Right. It almost like could bring the data center full circle. And I really wish there was more opportunity like there is in Europe around district level heating in the US because I feel like it would be such an obvious use case. So I'm a little more bullish on some of this in the near term in Europe than in the States. But I think good public partnerships with where you're developing and if you're in the right area, you can offer some of that heat that you've captured to surrounding businesses, whether that's an industrial process or whether it's kind of commercial developments, like you could potentially offer that up. Um, you can also look. The other thing too is like you talk about power generation. There's on-site power generation that's coming for a lot of these. Right, and there's a lot of waste heat that's generated there as well. And so you could look at adsorption chillers, for your product and use some of that waste heat to actually use to generate your cooling processes. So there's a lot of excitement there. I think it'll be a little bit of time till we see some of that really deployed in scale. Same kind of reason we built the advanced compute testing lab. Like we want to make sure it's going to fit in your portfolio and you can maintain your uptime and resiliency. And then I think you can fold in some of these more newer technologies and try to take advantage of that. But it's coming. It's a benefit of the advanced compute systems that we're seeing today.
You mentioned on-site power. A lot of folks who are building at scale right now are, thinking about either on-site, co-located, adjacency to power. How is Aligned thinking about the opportunity going forward in terms of doing new things with energy?
So no doubt it's a new reality for all of us data center developers. We used to be kind of inside the four walls experts, right? And over time we've had to become experts in land enablement and land development, getting these utility sites, getting the site permitting done, getting air permitting. Now we've had to bolt on the next piece, which is really like power generation. And so like our purview continues to increase on this front. So the way I like to look at it is tools in a toolbox. I don't think anybody should ever sit there and be like, there's one specific behind the meter solution for all these opportunities. The reality is you have to have a good understanding of your site dynamics. Is there natural gas adjacent? Your utility dynamics, for instance, is the utility constrained because it's a generation problem, or is it a T&D problem? Is it a coincident peak problem? Depending on what that problem may be, you might have a different solution that works. Like a battery energy storage system. One of my favorite solutions for when you're looking at like a coincident peak issue. And so you end up with a variety of solutions that I would say short term to long term, and they look like could be nat gas turbine development, could be battery energy storage solutions, could be fuel cells, all in the short to medium term. And then I like to look at technology out that's 5 years plus out, which would be something like a small modular reactor. I personally am very bullish on the small modular reactor space. We spent a lot of time and effort in that space with Aligned, because it alleviates potentially all three of the major grid issues: T&D, and generation. So I'm pretty bullish on that. We are working to understand how our plans in the early 2030s could be impacted by the development of that technology. But the reality is you got to cover all your bases. You got to understand your site. You got to understand your constraints, and then deploy the solution that matches the site and meets the customer's workload needs.
You mentioned a couple of technologies, fuel cells, battery energy storage systems that have traditionally been of interest, but maybe had some, cost issues. They were at least perceived as being, premium products in terms of their pricing. Is that changing? It sounds, from what I'm hearing, it sounds like some of the economics of that are improving.
I have seen improvement in those. I mean, the battery economics are one that I think everybody can read about how those economics have been improving over the last couple of years. And what I like to think about, like the financial considerations around some of this, it really depends on what you're comparing it to. Like you could have a utility solution available, but in order for the utility to get you that energy, you need to invest hundreds of millions of dollars in new generation and new T&D to bring you the energy. And so at that point, you evaluate a secondary energy source, and that may actually be more economically competitive, even if higher than what would be like a typical 5 cent, 6 cent, right, ERCOT type of price. And so I always like to think of it as like you got to look at what your options are and compare them, and the economics fold into that from a perspective like of those different options. And to some extent, like you could even argue you're comparing it against having nothing, right? And so there's also the approach of I need this capacity, need to figure out how to make this work. I understand that a behind the meter solution may come at a slight premium to grid, depending on the capacity factor and the utilization of that infrastructure, right? The more you use it, the better that energy cost is. But my alternative is I can't stand up my workloads. And so just having transparent conversations about that, having those tools in the toolbox, understanding the pros, cons, and economics allow you to kind of put the array of solutions on the table with a customer and figure out which way you want to go. And that's basically the way we are handling it.
You mentioned before that you had worked in supply chain. I know supply chain is something that Aligned has thought a lot about over the years. Uh, and these are interesting times for the data center supply chain. How would you sort of assess the status of the supply chain in 2025, and how Aligned thinks about working with supply to be able to keep up with all of these enormous campuses you're building?
It's a great question, and it's one that is a continuously evolving situation, as you just said. Um, I'll walk back maybe a little bit. So like, yeah, when we started the supply chain group at Aligned, there's really kind of two approaches you can take in the data center. So you could buy everything once you have a project, once you sign a lease, and you can kind of try to just in time it to projects. Pros and cons to that approach. One of the major cons is you're taking a risk of the market. It could be late. Economics could change. Tariffs could impact something. You're a little bit more susceptible to what the market is doing. So we developed a supply chain program that we call our Aligned Vendor Managed Inventory Program, or VMI, and we do programmatic buyouts based on forecasts. And with the harmonization of our supply chain and our design, we are able to use those components generally across the United States with minimal to no changes really to that kit. And so that gives us good flexibility for demand changes or customer changes and being able to meet that with our equipment. So you get that benefit of locking in your supply chain early at kind of a fixed price and insulating yourself from a little bit of the what could come as that order works its way through over the next 24 months. And so we like to think about it from a strategic lean in, buy in bulk, get the economy of scale, and de-risk the portfolio from that perspective. And when you do that, it also gives all of your providers excellent for they have the orders, they understand what's coming, they can make the investments in the capacity to make sure that they can meet your next order needs. So you kind of get that twofold adjustment. And the last thing I would say that I think is pretty important is if you can get out far enough ahead of it, you generally can have a what I like to call a U.S. centric supply chain. Um, that's been our strategy since the very beginning was to try to get 100% of our final component assembly in the United States. There may still be subcomponents that come from certain areas. Samsung batteries are always one that is some of the best battery technology. They come out of Japan or South Korea. Um, but if you can have a very U.S. centric supply chain, you can insulate yourself from tariff risk. You also have the best support for those products because they're U.S. based. And so we also have a very strong U.S. focused buying program, and I think that's been very helpful to insulate us from some of the dynamics from April 2025 to that we're kind of still continuing to see, although leveling out a little bit and maybe stabilizing some.
I'm always just amazed at in recent months the scale of the announcements that we've been seeing as we've gone from in just a matter of a little bit more than a year to from hundreds of megawatts seeming like it was enormous to suddenly there's so much discussion of gigawatts and multi-gigawatt campuses. Uh, does that change the timeline in terms of when you're thinking about supply chain and how far ahead you have to work? uh, Both because there's more equipment involved and there's more people who seem to want to be in the game these days.
It's so funny you say that. Like I feel like everybody has become a little bit immune to these numbers. Like 2017. I mean, when we were a smaller business, a 1 megawatt opportunity, everybody from our C-suite down was working on the 1 megawatt opportunity. We had to fight. And it was fun, to be totally honest. Now you're talking about 1 gigawatt opportunities, and it's almost being talked about like no big deal. But as I think you would appreciate, I think most of us appreciate who have to deliver this. It is a big deal, um, but we can get there. But you have to have the right ingredients for success. So, like, take supply chain for an example. You might get a question like, "I need a generator. When can I get a generator?" 52 weeks. That's a generator. I need like 600 generators. And so like the conversation is not just like when can I get the first one? It's actually moved from when does the last one show up and what is the capacity and pacing that needs to happen in order to meet these timeframes. And when you start to lay that stuff out for a gigawatt single opportunity, you find that you need triple digit megawatts a month of deliveries. The only way to be successful with that is to be in front of it early, forecasting that with your partners, locking up that capacity, and adding on vendor diversity to potentially fill the holes. And if you don't have that strategy in place, a gigawatt is not going to come online when you expect it to be. In order to do that, this is where the engineering design piece comes in, right? You need a consistent engineered product because you need to know what you're going out and forecasting with these providers, what you're actually putting on a purchase order and locking all that stuff down. So they get the harmonization of those two things have to be really hand in hand and be. It's one of those areas like I like to think like at Aligned we are very zippered in that area. They both report in the same go-to-market group, which is my group at Aligned, and bluntly our job is to make sure that is tied together so we can make those investments, so we can set that up for success, so our construction teams can really build and turn these over. And then the last piece I'll just add is startup and commissioning. Startup and commissioning, there's already a shortage of excellent, experienced commissioning agents in this country in particular. As you go to a gigawatt scale, and we're talking turning again over triple digit megawatts a month, the commissioning plan, the people you have on that site, the advanced commissioning you potentially do in the factory to reduce commissioning on site are all things that you've got to consider when it comes to these massive projects. So it is an amazing opportunity and an amazing challenge all at the same time. And so I'm really enthusiastically embracing it. So is Aligned. You know, we're excited about where the future holds, but we need to make sure we're setting everybody up for success.
Let's talk a little bit about the future. I think that's a good place to close. You've you're someone who's been working at Aligned for a bunch of years in looking at high performance data centers and how you design and operate them. Meanwhile, we're in this environment where, as we just mentioned, we're going to gigawatt scale at the same time as we're seeing dramatic increases in density. Um, I guess I'm curious how you're thinking about the future and what you need to design for and think about. Obviously, you guys have been innovating with introducing Delta Flow, having the advanced cooling lab. How do you view your job in terms of sorting out the future requirements in this kind of crazy environment?
It is a crazy environment to say the least. It's funny. It'd be one thing to do all that and kind of keep with the typical pace of data center industry, 10% CAGR, which is still exciting in its own right. But we're trying to figure out how to change the engines on the plane while the plane is in flight, and we need about another 100 airplanes. So it's certainly an interesting, challenging effort. I still think that we're in this kind of adaptation phase for now. I think that adaptation phase is we're going to stay there to some extent until the supply chains and the technology can catch up with some of this at scale. If you called and needed 1 gigawatt of a bespoke electrical item that is maybe optimized to advanced compute, but you may not be able to get 1 gigawatt. So you fall back to what can you get at scale, and it's still a little bit of a handcuff to some of these developments that are going to be coming. But I do see that optimization of the facilities, towards the end of the decade, certainly on the horizon. And I think it's going to be around a few different areas. One, I think for the advanced compute systems, that densities is going to continue to rise a bit. I do think it won't continue to rise indefinitely forever, as thermodynamics and these other things are true, constraints around some of this. But that will continue to rise to a certain level, and we have to be able to support that. Supporting that, I think, means higher voltage out to the floor. So, I'm personally a believer in the 800 volt DC architecture, some of the Mount Diablo stuff, OCP items. I think that just makes a lot of sense. If you can increase the voltage, you can reduce the amperage, but you need to keep the safety for the personnel at top of mind. I think that's the right sort of solution to be looking at in a few years. And that supply chain's got to stand up. The powered shelves and the racks have got to change. The infrastructure we provide has to change. It's got to be built. It's almost like liquid cooling that we started 2 years ago. I think we're starting on some of that now. So I think a lot of that makes sense. And when you look at high voltage DC, there's also optimizations you could potentially do your power backplane at the same time. And you could potentially look at a full-on DC solution from call it a fuel cell all the way to the rack. It's on the table. I think it'll take some time to get there, but it's on the table. I also think there's going to be some innovation in backup energy, generation. Like, this is an area of particular focus of ours is, diesel generator. Everybody loves the warm embrace of a diesel generator for an obvious reason. It is reliable, and when your job and your workload depends on it, you want to run to your diesel generators. But we know that that's probably the least sustainable portion of the data center portfolio, and one of the heaviest capex spends we have for a facility is all the backup generation. And so, how can you augment the backup generation, potentially still staying with diesel, but adding different componentry there to make it a little more sustainable or perform a little bit better against advanced compute workloads, reduce those emissions a little bit further? Like, I think that there's going to be some good innovation on that front that's going to help these facilities out. And lastly, on the cooling side, I think we're going to see continued innovation on the heat absorption front. I think the two-phase direct-to-chip is something that makes a lot of sense. I think we may see that before we see any sort of wide-scale adoption of immersion or some of these other things. I think the two-phase makes a lot more sense. And then, like you mentioned, on the heat reuse, the higher supply and return water temperatures, that will unlock some additional benefits in terms of what we can do free cooling, what we can do with it. When you add those things together, your peak PUE is potentially going to drop. You're going to be able to do more with the watts of energy you have allotted. And so those are some of the steps I see to optimization in the future. But it's doing it in the right way, because at the at the fundamental first principle of this entire industry is uptime and reliability. And so we can't just jump into it. We can't just say we can do a gigawatt of it. Instead, we're gonna develop those products. We're gonna test those products. We're gonna implement them in our designs when we feel comfortable that we can uphold our resiliency requirements to our customers. And that's a big focus of ours over the next couple of years.
Well, listen, this is such an interesting time in terms of both the scale and innovation that's going on. And Michael, I've really enjoyed taking some time to talk with you, nerd out a little bit on data center cooling and power. So I appreciate you taking time to come on the show.
Pleasure. Really, thanks for having me. It was a good conversation.
And to our listeners, thank you for tuning in. If you've enjoyed the conversation, be sure to give it a like or a review, and be sure to subscribe to our channel and either on YouTube or on whatever podcast app you prefer, so you can be right up on the latest content from Data Center Richness.